Okay, welcome back. We're talking about functions. So I have a table valued function here and a scalar valued functions. So one more time, a table valued one, you just close your eyes and pretend like it's a table, just like we did a view. And then scalars are not like that. Scalars produce a single value, and therefore they're typically used inside a select statement, not a from statement. Okay, let's just go through it one more time. So, what are the rules for creating a scalar function? Well, this is one of the few places where those dang semicolons are kind of required. And you could actually make this a little prettier if you wanted, and like do it like this, where you indent the actual code part. I mean, you don't have to, but so you declare a variable, and then you use this really strange syntax with the equal sign. We've never done that before. So now's the time to kind of look at it and go, oh, okay. All it is just a select, and then we put a variable and equal sign, and that makes all that stuff happen. But it only works for a scalar, which means it only happens for like integers and strings and, dates and, simple data types, not rows of data. Okay, good. All right. And then in the select statement, I could hard code this. Okay, I could, but that wouldn't make any sense. If I hard coded this to 1, right? Well, then for every student, it's going to say, well, they have two phones. No, they don't, right? So I don't want to hard code it here. Typically, I would not hard code it. I would put, a variable here. So this is the student. It gets passed on to this guy. Okay, kind of making sense? Good. Okay. So it's used as a column in the select clause. Okay, good. Okay. On page 373, they talk about triggers. So what is a trigger? Well, a trigger is, I want something to happen automatically. It's like every time I insert a row in this table, I want to do something else. Okay? That's what a trigger is all about. And so you can set things up where you tell the table, hey, whenever somebody deletes something or updates something or adds something, whatever it is, you could say, I want you to do something else. So you could have, a lot of databases have like different types of triggers. You could have a before trigger. In other words, before it does the insert. We don't actually have that one in Microsoft SQL. You can do an after, which means after it's done the insert, do something else, or instead of. Okay, let's say, for example, you've set the student thing up so that when you attempted to delete a student, a trigger would fire that says, no, we're not doing that. I'm going to, instead of deleting that row, I'm going to go to that row and change the active from a 1 to a 0. That would be an excellent use of a trigger. So if you forgot that you've set this thing up, the trigger could fix it so that if you typed it in incorrectly anyway, it would fix it for you. Okay, so we're not actually going to do one in this class, but you need to kind of know what they're for. So here's some talks about triggers. Yes, you can have default values that are complex. The default value now is a constant, okay? Like state is Texas. Cool. But trigger could be, well, if they're from Texas, the discount is 4. But if they're from Louisiana, the discount is 3. You can have some logic behind it. You can't do that with a default statement, right? So triggers could do that. Enforce data constraints that are kind of complex. Remember we talked about how the only tools we have in our toolbox is making the primary key null or not null, and then in the case of a one-to-one, whether or not you may have a unique constraint on it. And that's the only tools we got. So I can't, when we talked about how I can have a mandatory parent, but I can't have a mandatory child. Well, with the trigger, I could say, now wait a minute now. After we've done this thing, I want to go fix it up. Updating views. I mentioned that updating views is very complex. And so I'd recommend you don't do it, but if you did, this is how it would work. And then perform other bizarre referential integrity actions. Way back, I mentioned, what happens if you have, instead of a one-to-one or a one-to-many, what happens if I have, there has to be exactly 4 people on a team. Exactly 4. Can't have 3, KNF5, exactly. Trigger would be a good one. So, default values, data constraints, some sort of complex business rule that depends on something else. A discount, maybe it's a discount based on the size of the order. You know, if you have more than $100, well, shipping is free. That kind of logic behind it. Cool. Updating views and, of course, referential integrity. All right, stored procedures on page 381. Again, this is where things get really complicated. This is where you actually write an application in the SQL language. And yes, it has if statements and where and loops and, you know, everything. We are not going to do that in this course. So basically, it's a small program written in that persistent stored module language, okay, which is almost always very tightly tied to the vendor. So if you wrote a stored procedure in Oracle, chances are it probably would not work well in someplace else. Okay, so let's talk about what they're used for. The number one reason that I think people should use stored procedures is the surgical application of security. That's my number one reason for using stored procedures. Let me give you an example. Let's say, for example, that you have an employee table and you allow the employees to go in and alter their own record. Like they'll go in there and they'll change their home phone or something, or change their address, or maybe, you know, change their last name or something like that. Several of the fields they have permissions on. Not all the fields, but some of them. So several things here. They can't change their pay in the employee table. They could look at it, but they won't be able to change it. So I need a surgical application of security. Furthermore, I don't want them to see anyone else's data at all. Now, I can't bring up my boss's record and look and see how much they're being paid. Okay, so a stored procedure will zero me in on my row and only my row, allow me to have complete control of what I can see and not see, and complete control over which of the 7 columns, 3 of which I can make changes to. A surgical application of security. You think maybe there's a reason why I repeated that 3 times? Gee, you'll never know. So you don't actually have to have write permission on the employee table at all. You could have it done through the stored procedure, and the stored procedure would actually have the permission. You would give permissions to the stored procedure, but not to the table. Good. Okay. It used to be in times past that these stored procedures were actually faster. That's not the case now, but in the old days, what happened is it would pre-compile or pre-optimize or whatever. Pre-optimize the query, so it wouldn't have to think about it a minute. Hey, how am I going to solve this query? It would think about it in advance. Those days are kind of gone now. But you'll still see this on the internet. Well, stored procedures are faster. Okay, they used to be, but not much now. Hiding complexity? Yeah. I mean, this could have a very complex thing going on here. I mean, you could have all sorts of weird things. You could say, wait a minute. My stored procedure, unlike a trigger, we can hit a table. I could go here and say, let me go back and look at the last 12 months worth of data on this customer. Oh, he's a big spender. I'm going to give him free shipping. Okay, that kind of stuff. Weird business logic. And then, of course, application programming. If I'm writing an application for a web, I have 2 choices. I could put the business logic in the application, or I could put the business logic in the database. Some people love to have it in the database. That way, if somebody breaks through the security barrier of the web page, they can't do anything because all the web page does is just talk to these stored procedures. And like there is no stored procedure for destroying all records. In other words, it limits the amount of things that you can do. Okay, that's one way of doing it. Okay. So we're not actually going to do this. We're not actually going to do stored procedure, but you need to know what they're for. Okay, here's an example of triggers versus stored procedure. So a trigger, it's a module that's actually when an insert, update, or delete command are issued. You can assign it to a table or a view. Okay, depending on, you may have more than one trigger. There's a way one trigger can cascade another trigger, right? Let that happen. And, other things. Stored procedure is a module that's outside of a table. It's not assigned to a table. It's a separate thing. Assigned to a database, but not to a table. And it can do inserts and updates and deletes and merges and all the rest of those things. And then a repetitive task that, all part of an application or something. Okay, so let's talk about the advantages. Greater security. Yes, the number one thing is the surgical application of security. I said it 4 times. If that's not a hint, I don't know what is. Decreased network traffic? Nah, okay. SQLs can be optimized? Not anymore. Code sharing. Yeah, once some programmer has figured out how to do this, and this, I don't have to reinvent the wheel. I can just go borrow. Less work to happen? Yeah, it could be more efficient. Standardized processing and specialized among developers. Those are kind of cool advantages of stored procedures. Okay, one more time. Let's say I have only read permission on an employee table, but I have a stored procedure which gives me read and write permission. Which permission is going to prevail? Okay, good. The very last table is this thing talking about user-defined functions and triggers and stored procedures. So, can accept parameters. That is the number one distinction between a user-defined function and a view. Views aren't on the list here. So triggers, no. Triggers happen when an insert occurs. And you can go get the data being inserted. Okay. Stored procedures, sure, you can pass things. Can return the result. Yeah. Can be used in select statements. Sure, not stored procedures. Can use a select, yeah. So user-defined functions were not really intended to update the data. It wasn't intended to do inserts or updates or deletes. In other words, a user-defined function typically was designed to I'm going to go ahead and say this, read-only. Okay, it was designed to be read-only. Not so with stored procedure. I can insert all day long, soak in a trigger. I mean, a very common use for a trigger would be every time somebody messes with the table, I want to create an audit log of who did it and when and where and why, that kind of stuff. So yeah, can invoke a trigger. Well, yeah. Can invoke a stored procedure. Yeah. Is stored as a database object. Okay. User-defined function. That's why I had to use, when we were using the scalar guy, I had to use DBO because it was a database object. And then stored procedure. And then is stored as a table. Triggers are stored as the table. Okay. All right. So we are going to go over this again in Chapter 10 with a specific example geared to help you with like your term project. We're actually going to be building some table functions and some scalar functions, and we're going to do it again. But this is all good information about, views, functions, triggers, and stored procedures. Okay, we made it to the end of this chapter. I'll see you guys again in the next chapter.